Sawadee everyone, my name is Tang. Do you see the building at the back? They are made up of concrete. Many people might wondering what I mean by concrete. Concrete is a mixture of Portland cement, water, aggregate, and in some cases, admixture. Cement and water form a paste that hardens and bonds the aggregate together. Apart from wood, steel, and composite material, concrete is a material that is widely used as a construction material as it is versatile, it has great compressive strength, and its cost is relatively low. Since concrete is a structural material, so strength is a desirable property and it is the most common performance used by the engineers in design building and other structures. Compressive strength is to determine the mixture of the concrete meets the requirements of the specified strength in the job specification. The normal compressive strength of concrete ranges from 14 to 42 megapascal. And let me review you the fact that not many people are aware of. Concrete can actually made up to withstand over 70 megapascal for special jobs. Isn't that amazing? Apart from compressive strength, there is another important characteristic of concrete. It is Young modulus. It is the measure of ability for the material to resist the plastic deformation under the load. There are several standards to be compared with, for instance, ASTM C39 for compressive strength of concrete cylinders and ASTM C469 standard test method for static modulus of elasticity and Poisson ratio of concrete in compression. There are two types of factors affecting compressive strength. First, intrinsic, and another one is production related. Intrinsic factors are property of raw material, mixed proportion, and age, while the production related are compression, external environments, and curing. Well, are you audience looking forward to watch how we test for concrete compressive strength? I have made an appointment with students from Civil Engineering Department who will now show us the proper steps to carry out the test and get ready to watch and learn. And here is my true friend from Civil Engineering Department who will show you how to perform the experiment of compressive strength and modulus of elasticity of cylindrical concrete. Okay, let's begin.
Sawadee krab.
สวัสดีค่ะ
There will be 4 of us in the lab for today, and I am Petong.
I am Ong. Fear better and after we finish the guiding process.
First, put the metal block and ensure that it's aligned with the edge of the table. Then, turn two locks at the side to lock the metal block. After that, put the specimen on metal block and push it until the surface is in contact with the blade. And lastly, turn the top lock to lock the concrete specimen tightly to the metal block. Now it's time to start grinding. We will steer this wheel slowly about one complete turn. We will remove all the locks from the specimen to check for its perpendicularity.
I will use vernier caliper to measure the dimensions of the specimen. There are two specimens for this test. First, I will measure the diameter of the first specimen. The diameter is 100.6 millimeter. Next, the height of specimen. The height is 198.2 millimeter. After that, I will measure the second specimen dimensions. The diameter is 100.6 millimeter. Then the height. The height is 200 millimeter.
we are going to show you how to test for compressive strength of concrete. Can you please take the sample for me, please?
Here you go.
Thank you.
The test is short and simple. We will begin with the first test. The first test is according to ASTM C39 standard test method for compressive strength of cylindrical concrete specimen.
The objective is to obtain the value of compressive strength of concrete specimen such as mold cylinder.
Right, the apparatus we will use today is universal testing machine and cylindrical concrete and smooth surface.
We choose cylindrical concrete specimen because for research purposes, cylinders are believed to give a greater uniformity of results compared to the specimen of square cross-section.
Let's begin.
To begin with, we will place the concrete cylinder into the machine and center the specimen. We may put some square metal blocks below the specimen as the base. Firstly, we set the percent fail to 10%, base to 10 kN, rate to 10 kN per second, and the target to 100 kN. Next, we set the tearing conditions. The drop time, stop level, and maximum are set to 1 second, 10 kN, and 100 kN respectively. After that, we set the sample to non-standard cylinder and input the diameter and height of the specimen. After we finish setting up, we go back to the main page, and now we can begin the test by pressing top right button and just wait for the machine to stop automatically. On the right hand side of the machine, we turn the shaft to closed to make sure that the machine stops compressing once the specimen fails. While on the other side, we turn the shaft to compressive. The ultimate force is 182.1 kN, and therefore the compressive strength is 22.91 megapascal.
Okay, now we are done.
No, we need to do one more test. We need to find the Young modulus of the sample as well.
Oh yes, how it is different from the compressive test?
They are actually similar, but for this time, we only need to compress until 40% of its ultimate load.
Okay, got it.
Yes, other than that, this test is performed based on ASTM C469 standard test method of static modulus of elasticity and Poisson's ratio of concrete in compression.
But unfortunately, we don't need to do the Poisson ratio for this time, right?
Yes, that's right. Then repeat the test, and then we need to derogate and compressometer.
First, I put two large steel bars under the compressometer to prevent the compressometer touching the surface or the ground. Then, I put the needle to support upper and lower part of compressometer. Next, make sure upper and lower part are vertical if we look from top view. After that, we lock the screw on the steel plate that was attached to upper and lower part in order to make them stay in place. Then, put the sample into compressometer and tighten all of the screw to keep the sample stay at the middle of compressometer. Lastly, we use the level to check if the surface sample parallel to the table. Then, loose the screw to take out the steel plate before taking into the machine.
First, press the P-test button. Then, choose compression for new test setup. Next, set the base as 10 kN, rate as 2 kN per second, and target as 100 kN. After that, Choose the sample option to be non-standard cylinder, then set the diameter to be 100.6 mm. Next, set the height to be 198, then press back. Press back again until it comes back to the main setting layout. Then, press pump. Next, press button number 4 to go to overview layout. We can also change the speed with speed controller. For modulus of elasticity, we need to record the gauge reading from the dial gauge. We will read the gauge every 5 kN of compressive load. From gauge reading, we can obtain deformation values.
Next, after we finish the test, one will show you how to calculate modulus of elasticity of cylindrical concrete.
Let's start. To calculate compressive strength, you just need one simple step after area is calculated by using pi r squared. You have to take ultimate load divided by the surface area which the load acts on. The compressive strength is equal to 0.023 kN per square millimeters, or 23 megapascal. The failure type of our sample is spreading. From the experiment, we will obtain load in kilonewton and gauge reading. After that, we will divide gauge reading by 2 to get deformation. Next, strain is obtained by dividing deformation with original length. Then you need to plot the graph of stress against strain and find sigma 40% of ultimate stress, while epsilon 40% is the strain at sigma 40%, and sigma 1 is the stress corresponding to epsilon 1, and epsilon 1 is 0.0005 to obtain Young's modulus. The formula is based on ASTM C469, which is the Young modulus is equal to sigma 40% minus sigma 1 divided by epsilon 40% minus epsilon 1. Therefore, the Young modulus is 36.57 kN per square millimeters.
Thanks to all my friends who helping us to demonstrate the test, and finally, we all know how to perform the test of compressive strength and modulus of elasticity of cylindrical concrete correctly according to the ASTM. Thank you.